Good morning. Today we are going to see assignment number 5. So we have assignment number 5. Which of the following is the conjugate beam of the statically indeterminate beam given? So now you can see over here. So we have given that is real beam, and to that real beam we have given conjugative beam. What does it mean? So that is, if you have fixed support, it becomes cantilever. If your cantilever becomes fixed, then if you have continuous support, becomes internal hinge. If your internal hinge becomes continuous support. So mainly we are with 4. If you have fixed support, then that becomes continuous support, that becomes free end. If you have free end, that becomes fixed support. If you have internal hinge, then it becomes continuous support. You can see over here in 5th, you can see we have internal hinge which becomes your continuous support. And if you have continuous support, it becomes internal hinge. So now you can see we have this problem. So we have first fixed support, this becomes free. Then we have internal hinge. So you can see 5th, internal hinge becomes continuous support. Means here we have free, then here we have continuous support. So we have continuous over here. And then we have third, simple will remain as it is. You can see simple remains simple, roller remains roller. So we have this remains as simple. So now you can see which option is the correct one. So we have option A. Now we will go to the second problem. The bending moment diagram of a beam is shown figure below. Which one of the points might be the correct supports and loading for the beam? Now you can see between A to C, we have linear line. When we have linear line in bending moment diagram, when we have concentrated load. Concentrated load. And when we have parabola, C to D, when we will have parabola, so we have parabola when we are being with UDL, uniformly distributed load, or UVL. UVL gives you cubic parabola, but nothing is mentioned over here. So in A to C, we require concentrated load. And in C to D, we require UDL or UVL. And we have this will be the beam in which we have A to C, that is concentrated load, and C to D we have UDL. So we have option is C. Now in this we have concentrated load, but as here we have UDL, so it should give parabola. And therefore correct option we have only A to C, we should have UDL. So option is C. Now we have determined the slope and displacement at the free end A of the beam with constant EI using conjugate beam method. So in conjugate beam, what are the steps? We have to first draw the conjugate beam, and on this conjugate beam, we have to consider loading as M by EI diagram. Loading on conjugate beam is M by EI diagram. And then you have shear force gives you slope, and bending moment gives you deflection. Now we can have this beam 6 kilonewton 3 meter. So we have this as A, and then we have B. Then bending moment diagram we have in this first A becomes fixed, B becomes free, and bending moment diagram at A we have 0, at B we have 6 into 3, so 18 kilonewton meter. Now we are interested to find slope and displacement. If slope is positive, then we have anti-clockwise. And if bending moment is anti-clockwise, then deflection is downward. And then we can see this. So we have, this will be total load, half into 18 into 3, because we have triangle. And for triangle, we have area of the load diagram. So these two gets cancelled. And we will get it as 27 upon EI. And that will be my reaction, 27 upon EI. Bending moment, now you can see, we have distance from this is 2/3 of 3. 3 gets cancelled, and we have 27 into 2, so that will be 54. Sorry, this is 54 upon EI. Now deflection, we have downward anti-clockwise, shear force positive we have, and therefore we will get this slope that is anti-clockwise. So we have counterclockwise and downward. So we have option is A. Now, if you will see this beam, so this beam will deflect in this fashion. And if we will apply tangent to this, then we have this will be counterclockwise. And deflection we have downward. So option we have, that is A option. Then we have, this will be determine the displacement and slope. So displacement we have to find out M at C, and slope means we have to find V at C. So slope at C, that is shear force at C, and bending moment at C, that is displacement at C. Now this is conjugate beam. So we have this as conjugate beam. Sorry, this is given beam. So we have this, I will mark it as given beam. Given beam. Now you can see, now fixed support becomes free, that we know. So this is free. Then this we have B, A, C and D. Now B we have internal hinge, it becomes continuous support, and D we have roller, so it becomes a roller. Now we have to find bending moment diagram. So now for bending moment diagram, we have to take moment about hinge 0 from right side. Then what we will get, if I will say this will be reaction RD. Then how we will get reaction RD? So we have moment about B equal to 0. And then we have RD into 6 equal to 25 into 3. And from this we will get value of RD, that is equal to 12.5 kilonewtons. So we have RD 12.5 kilonewtons. And summation Fy0, we will get Ra in the same fashion, 12.5 kilonewton. Now we will draw the bending moment. At B, we have bending moment 0. So if we will take bending moment 0, then we will get value of MA, and that value we will get it as 12.5 into 3, 37.5 kilonewton meter. And now we will plot it. So we have, these are 3 meters. So this is 37.5 kilonewton meter. Then we have at this point 12.5 into 3, again 37.5 kilonewton meter. Now whatever shear force we will get at C will be slope at C, and bending moment at C will gives me displacement at C. Now we will take moment about B0. So if I will take moment about B0. Now we have bending moment due to this. So we will get clockwise, so 1/2 into 37.5 into 3 into bending moment. So we have at B, so we have to consider distance from here, which will be 2/3 of 3. And then this becomes 2 meters. So into 2. This will be clockwise, plus due to this BD. So we have plus 1/2 into 37.5 into 6. It will act at center, and therefore we will get total load will act at center. So it will be into 3. And bending moment due to RD again, and that will be RD into 6. And from this we will get value of RD, that is equal to, just I will calculate it, 37.35 into 3 plus 37.5 into 9 divided by 6. So it comes 75. So RD is 75 kilonewton. Now we have this as point C. So now shear force at C. So just I will change the color. So we have shear force at C equal to, now RD, we are considering left side. So plus minus sign is not required. Otherwise we have to consider upward minus. So now I will consider 75 upon EI and minus 1/2 into 37.5 upon EI into 3. So you just try to understand which portion I have considered. So this is 75 upon EI, which is my reaction, and this 37.5 upon EI, which is load, which is downward. And from this I will get it as 37.5 into 3 by 2 minus 75. So 18.75 upon EI. Now this will be slope, so theta C. Now we will go delta C, which will be bending moment at C, which will be equal to 75 upon EI due to reaction into 3 minus, this will be as it is, 1/2 into 37.5 upon EI into 3. And now we have to find distance, that is centroid from this, and that will be 1/3 of 3. So it will be 1 meter. So into 1 equal to, so we have this as 37.5 into 1.5 minus 75 into 3. So it comes 168.75. So now we have deflection 168.75 and slope 18.75. So we have option is C. So likewise, we have to solve the problem. Remaining we will see in the next video. Now we will stop here only. Thank you.